Alright, it's lesson 9.3 and we're talking about area. And how do we find area of a polar curve? Well, I've given you the formula here. The polar area, one more thing to add to your formula list, 1/2 integral from alpha to beta, and those are two angles because it's d theta. So integral from alpha to beta of r squared times d theta. And if you're thinking, this looks kind of familiar, remember pre-calc 12? Don't know if you remember section 4.1, I think, part 2, where I asked you to find the area of a sector, and that was this formula, 1/2 theta, and then r squared, remember, when theta had to be in radians. Well, I hope you can see that looks very similar to this. And if you're looking for the proof, go to your textbook, it's there. Okay? But I'm not going to do that right now. So, let's take a look at example number 1. Find the area of one petal of the curve r equals 3 cos 3 theta. And I'd ask you to always try to sketch out the graphs first. That will give you a good helping and indication of what you need to do. And if you think about what happens here, you'll see that when theta equals to 0, cos 0 is 1, 1 times 3 is 3. Starting here, and this is 3 theta, so I'm thinking, like, for example, pi over 6. Pi over 6 times 3 would be pi over 2. Cos pi over 2 is 0. So at pi over 6 it goes back to 0, so it's like one of these functions. Okay. It'll look like this. It'll look like this. Didn't draw that very well, by the way. Whee! Whee! And then back around. And all 3 of these petals are actually identical. So if I ask you to find the area of one petal, really I'm asking for this one here. And notice that this whole petal that I've actually colored in blue is also symmetric. Notice that this part in black will be the same as the remaining part in blue. So ultimately, really, I just need to find out the area of the black part, which is 1/2 of one petal, and then just double it to find my area. Okay? So the question is, how do I find the actual area of this black petal? Well, I need to find alpha and beta. That's the starting value of the angle. Notice how when I graphed out the curve, I began here and I rotated around. So I'll try to highlight this in purple. I started here and it went and notice that at this particular value here, the theta was equal to 0. And at this particular value over here, theta was equal to pi over 6. So how could I find those if I didn't graph this out? Well, notice that at that point r equals 0, so you could have just done this. 0 equals to cos 3 theta. Inverse cos of 0, well, that's what, pi over 2. And also, I guess, 3 pi over 2. And since those both equal to 3 theta, pi over 6, and also pi over 2, right? So because I'm using pi over 6, the first one, I'll just take this answer. Now, this is all just to find out alpha and beta, so now I'll plug this into our polar area formula, 1/2, the integral from 0 to pi over 6. It's r, which is 3 cos 3 theta, all squared times d theta. And that just gives you that black portion, remember, okay, that black portion. And then, in order to figure out the area of one petal, I'm going to have to double it, and that's the area. Okay? Well, 2 times 1/2, that's equal to 1, so really all I need to calculate is the integral from 0 to pi over 6 of this whole thing. I don't want to do this algebraically, so I won't. I'll just use the graphing calculator. And I expect you to do the same thing here. Okay? I don't think the AP exam will give you any weird, crazy things to actually calculate. And if they do, it'll be on the graphing calculator portion of the test. So, just go ahead, math. Oops. Let's go number 9, f and int. Plug in the expression 3 cos 3 theta, close the first bracket on the theta, close the second bracket on the function, square it, comma theta, because that's your variable, and you're integrating from 0 to pi over 6. Close the bracket and shabam! There's your answer, 2.356. So the area of one petal here is just 2.356. Okay? Alright. Pretty straightforward, I hope. Because now we'll move on to number 2. How do you find the intersection of polar graphs? Well, I've got this example here. I'm going to ask you to graph out r equals 1 minus 2 cos theta, and also r equals to 1. I think you can do that yourself, but if you can't, I will do it with you. Let me just make this a little bit bigger. Let's do the easy one first. R equals to 1. Yay! Right. This one you can use your calculator, but if you want to just go ahead and make a table of values, you may do so as well. Cos 0 is 1, so 1 minus 2 is negative 1. So at 0, it's actually at negative 1, which is here. And then it will probably swoop around. I'm thinking, what, cos of pi over 2, that's 0. So 1 minus 0 is 1. So at pi over 2 is actually at 1. So it's up here somewhere. So it probably went something like this. Okay. And then as we continue around, I'm thinking what happens at pi. Cos pi is negative 1. Negative 1 times negative 2 is positive 2. Plus 1 is 3. So it's now over here. So it looks like one of these cardioids. And I'll just graph out the rest for you. Whoop. Whoop. Like that. Okay? So, by looking at the graph, you can probably find the points of intersection already, but let's just try to do this algebraically. If I have r equals this and r equals that, just make the two r's equal to each other. So 1 minus 2 cos theta equals to 1. Negative 2 cos theta equals to 0. Cos theta equals to 0. And once again, know your trig. Theta must be then pi over 2 and 3 pi over 2. Which makes total sense here. That's pi over 2 and 3 pi over 2. Bravo. So the points are, and I can always plug it back in for r. R is 1, so 1 pi over 2 and 1 3 pi over 2. Great. Okay. And you're thinking, but what about this point over here? Good question. Shouldn't we have 3 points of intersection? How come I can't find the third one and my algebraic means only give me 2? What's going on? Well, let's just actually find that point first of all. How about we describe that point? It is on the unit circle, so we do know that the point still has a radius equal to 1. But what's the actual angle theta in this case? You can think, oh, it's on the negative side of the x-axis, so that's actually pi. That is correct. That is your third point. Okay? Now, how come we can't find this algebraically? So let's take a look, and let me graph this out on the graphing calculator for you. So r equals to 1 minus 2 cos theta. And then over here, r equals 1. Okay, graph. Now watch as we trace out the graph. And if I actually ask you to calculate what happens at pi, so go to your second trace button. I'm just going to go value and plug in pi. Notice that when r1 equals to pi, it's actually not at that particular point there. It's way over here. And at r2, if I move down, that's where you see the intersection point. So the key reason right now you can't do this algebraically is at pi, at this particular value of theta of pi, the two graphs aren't actually at the same location. Remember, the theta is like a parameter. like a parametric equation parameter controlling how to plot out the graph. And so pi is actually not an intersection point because they are actually at different values of r for the different graphs. So why do we see then an intersection point there? Well, what you have seen is that the actual curves don't collide at that point at the same time. They will reach that point somewhere along the rotation between 0 and 2 pi, but not at the same theta value. Okay? So they reach that point at different times, but the curves still nonetheless intersect. And that's unfortunately a complex problem that cannot be solved with algebra. So, my suggestion, you better graph out the curves. And having a graphing calculator will be very handy for you to do so. Okay? So, make that note. 1, 2, 3. By the way, there's another way to write this point. Okay? Bonus marks to be fair what the other way is. Okay? Bonus marks. You guys like bonus marks. I'll give them if you can tell me what they are in class. Alright, let's go ahead now and try to find the area between two curves. Remember how I said use the graphic calculator? Yes, please do, because these get kind of tricky. So, example number 3. Let's graph out those two curves. What are they? -6 cos theta. And once again, when you graph, it's important to see how the curve is actually created. Okay, 2 cos theta. Here we go! Graph. Here is -6 cos theta. And here is 2 minus 2 cos theta. Okay, so notice how -6 cos theta was created. I'll use that in the blue. It started here at -6, and then it went all the way around. Whee! Came out to here. Whee! Not a very good picture, but let's try again. What is up with this? Okay, my pen seems to be. Anyways, draw it. Okay. And then the other one, 2 minus 2 cos theta. Let's see how that was drawn again. So let me just quit this. Graph it out again. Oops, it's still here. I'll just trace. Press trace. Nope, I want this curve. So it starts here, and it went. Oops, and it went upwards. It's like the heart. Okay, so here we go. And we're over to 4. Go this way. Okay. I'm going to draw that circle a little bit better. I don't like the picture of the circle that I drew earlier. This one's not much better, but whatever. Yikes. Okay. Let's try a little bit better. Okay. No. Okay, get the idea. I don't know what happened there, but whatever. No, I'm not happy with that. Okay. Alright. So, if you're trying to find the area of the region common to the two regions, well, we're thinking about this whole part here, really in yellow. But maybe you can see some symmetry, so perhaps instead of looking at that whole part in yellow, can I just look at this part in yellow here, and then I'll just double my answer. Okay? I'm thinking this is probably a key point, because it seems like there's an intersection, so let's try to find that. You can use your graphing calculator. or you can use algebra. I'll just quickly use algebra. Negative 6 cos theta equals to 2 minus 2 cos theta. Let's see, that's negative 4 cos theta equals to 2 cos theta equals to negative 1/2. Inverse cos of negative 1/2, I believe, what's that? 2 pi over 3 and 4 pi over 3. So that point here probably is theta equals to 2 pi over 3. Okay. So now how do we set up this area? Well, it's inside, and I color-coded this, by the way, so it's inside the actual red one, which is the cardioid, so 2 minus 2 cos theta. If I were to look at what happens at 2 pi over 3, that's like this, starting right here. And if I were to now go all the way to there, that would be angle of pi. Notice what you will then get is just the area of this region here in green, which is okay, but you left out just a little bit, that yellow part. So at least let's go ahead and do that. Okay, so let's try to find the green area here. You just told me that would be the integral from 2 pi over 3, 2 pi of 1/2. R in this case is your 2 minus 2 cos theta all squared, and then we'll have d theta. We, remember, need to do that part, but we also have to add that last little sliver that's like this piece in purple here, which I just colored in red, or I'll just leave it as the yellow piece. Okay. And so how do I find that yellow piece? Well, that would be same formula, but now the question is, what is this value here? And I'm traveling along the blue curve. So the blue curve, of course, is the equation negative 6 cos theta. I can write that down first. But now, 2 pi over 3 seems to be my ending value of the angle. And the question I have for us is, what's our starting or beginning value there? And if you're not sure, we can go back to your graphing calculator and check. But notice, remember, I always start at this point and I went around. So I have a feeling that that would be pi over 2. But I'll just double check with my calculator. Let me get back onto the R1 curve. And if I ask myself to calculate the value at pi over 2, let's hope that gives me the origin. And yes, it does. Okay. So notice in this case here, this value here is theta equals to pi over 2 on the blue curve. So I'm going to go pi over 2. So really the area is just those two pieces added together. So add together. And then because that's only half of the actual area between them, we need to double both pieces. Okay? Double, double. And in order for you to calculate this, you will have to use your graphing calculator. Thankfully, the doubling and the half just means they cancel out. So I'll just use the graphing calculator and now type in the fn int portion. Just be careful once again with your brackets. Okay, so bracket 2 minus 2 cos theta. Close the bracket of the first, the second, that's this one. Now we're going to square it. Comma theta, comma 2 pi over 3, comma pi. Close bracket, that's the first part, plus, we'll do this both together, fnint, number 9, and the function is bracket negative 6 cos theta, close bracket, close function, square the function, comma theta, comma pi over 2, comma 2 pi over 3, and voila, voila, the answer is 15.708, and that's the correct answer. Good. Remember, round to 3 decimal places. Whew. Okay. How about if you don't get 2 curves, but I'm asking you now to find the area between the loops of the polar curve. Wow. So, graphing calculator to the rescue to give us an idea of what's going on. 2 bracket 1 plus 2 sine theta, close the bracket. Let's graph and notice how I actually draw the curve. Okay, notice how I started at 2 here, went up all the way to 6, whee, right, came back down to -2, whee, and then that loop-de-loop thing happened, right? So came to 2, looped around, went up to +2, whoop, down to 0 again, whoop, and then around. So in essence, I just want the area between the loops. Wow. The area between the loops. So one loop here, one loop there. I'm thinking, yikes. I'm looking at something like this. Double it. Okay? Wow. So, let's see if we can figure out some intersection points, perhaps. I'm looking at the key point where r equals to 0, so let's make r equals 0, and we'll solve, which really means 1 plus 2 sine theta equals 0, which means -1 equals 2 sine theta, which means sine theta equals to -1/2, which means inverse sine of -1/2 equals to 1/2 is pi/6. This is negative, so it's in quadrants 3, 7 pi/6, and 4, 11 pi/6. Okay. Well, what does that mean to us here? I guess what that means is that this initial point of intersection has a theta value of 7 pi/6. Curious here, so if I'm starting at this particular point at 6, what is the angle theta here? You could say that's pi/2, and I'd say that's correct. So if I went 0, pi/2, whee, all the way to 7 pi/6, I would have swept out that lovely area. I guess it would be this lovely area. It would be this one, including that extra bit there that's in white. So that's way too much, right? So that would be the green part. I'll do that right now. That would be the integral, so 1/2 going from pi/2 to 7 pi/6 of the function 2, 1 plus 2 sine theta, all squared d theta, but that's way too much. I have to subtract off a certain piece. So I need to erase the green. Oops, erase the function instead. Erase the green. Yeah. Erase the green. No. Erase the green. No. No, whatever. You get that in. Okay. So the key is now I need to get rid of this part here. And so my question to you would be, what is the angle theta at this point here? What is that? Because really then the blue portion is 1/2 going from, what would that be? I guess that would be 7 pi/6 all the way to there, that angle theta. And then I would have to subtract that part. Right, I want to subtract this blue piece here. That blue piece. And that blue piece I highlighted is equivalent to this blue piece over here, so either or is good. So the question is, what's that angle theta? That's when theta equals to 2. Oh, sorry, r equals to 2. And if you do some calculations, I hope you can find that that's going to be, I'm going to sneeze. Did you hear that? Did I give you enough time to think about what that's going to be for the angle? It's 3 pi/2. Okay, so think about it. If I plug in 3 pi over 2 for sine, sine 3 pi over 2 is negative 1. Negative 1 plus 2 times 2 is negative 2. 1 plus negative 2 is negative 1. Negative 1 times 2 is negative 2. That gives you the radius up top here, because 3 pi over 2 should be facing this way, and then r is going the opposite direction. So this theta is equal to actually 3 pi over 2. Okay. So the area between the loops would be then double of this minus the double of that. It so happens that the doubling is helpful because those just cancel out. And I'll leave this as an exercise for you to evaluate. I think the answer I got, 33.351. And I need to blow my nose. See you in class.